another Bioman activity. Here's the link that you're going to click on to get started. We're going to talk about the cell membrane and how things move across it. Specifically, we're going to talk about diffusion and osmosis. Diffusion, the movement of actual molecules, and then osmosis is diffusion of water. So when we get started, we're going to click start a new game, go through, and we have all these choices. If we look at the sheet that I created, we're going to click on the diffusion challenge first. So click diffusion challenge. We're going to read through our mission. So Dr. Ernest Lee Weil has come up with a way to freeze diffusion. Diffusion, as you know, is critical for the transport of necessary substances across the cell membrane. Anyway, enough background. Click and drag the molecules to perform diffusion for the cell until you reach dynamic equilibrium. Dynamic equilibrium, which is sometimes referred to as equilibrium, is when the molecules have diffused and are equally concentrated on both sides of the membrane. The survival of the cell depends on you. Good luck. So here we see we have carbon dioxide molecules on one side, oxygen molecules on the other. We need to get them across the membrane. So all you're going to do is you're going to click on one and drag it across, okay? We need to keep doing this until it's equal, all right? So I would count up how many of each you have and make sure you have an equal amount on each side. So if we count up, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon dioxide on this side and only 1 on this side. That's not equal. So I'm going to keep dragging them across until I have equal amounts. So again, count it. 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, still not equal. Now if I drag that over, we've got 5 on this side, 5 on this side. Now if we look at my O2, O2 has 2 on this side, 1, 2, 3, 4, 5, 6, 7, 8. That is not equilibrium. There's 8 on this side and only 2 on this side. So I'm going to drag more across. And now if we count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, that should be equal. So if you think you have it, click I've finished diffusion. If you didn't get it right, it's going to tell you to keep going. What you're doing on here is you're doing the same thing you just did. So you can click on these O2 and you can move them across the cell membrane. Okay? So when you're doing this, you should be making it so it looks the same as what you did on the Bioman. Once you have that done, scroll down. It says how many O2 molecules are in each side, so put a number. How many CO2 molecules are in each side, put a number. And then we're going to go into the next part, which is going to have questions. Okay, so you're going to go through and answer the questions, highlight your answers when you get the right answer. If you get it wrong, right, so if I get it wrong, it's going to say that's not correct. You have to keep going until you get it right. And then you go to the next question, okay? Once you have those questions answered, now you're going into the osmosis challenge. So let's click osmosis. This is just the diffusion of water. So this time Dr. Weil has disrupted the water balance of the cell. Cells must have the right amount of water to maintain homeostasis, a steady, healthy state, or they will die. Water moves into and out of the cell by a process of osmosis. Osmosis is the diffusion of water across a membrane from an area of higher water concentration to an area of lower water concentration. Okay, and then here's a demonstration. High concentration of water. Water is going to go across to the low concentration of water. Now, when we talk about osmosis, we typically talk about the concentration of the solute. So something that's dissolved in water, something like sugar water, salt water, any other things that are dissolved in water. The concentration of the solute is directly related to the concentration of the water. Okay, if there's more solute, so if you have a lot of salt in the water, that means you have less water. And if you have less solute, so if you have a little teeny tiny bit of salt, that means you have a lot more water. So you're filling in any of the blanks as you're reading through, okay? Blank words, fill them in. For this chart right here, it's on this page. So hypertonic is going to be higher in solute. So you're just going to fill in what's missing. So here you're going to put high. That means there's low amounts of water. Hypotonic, you'll read what it says. And then for equal for isotonic. Keep filling in the blanks as you go through as you're reading. we scroll down to this part. Now we're going to get into the actual cell membrane. So again, you're filling in the blanks. Now we notice here, we have the cell membrane, right? We have a bunch of stuff on the bottom that we need to put into the cell membrane. Only certain things are going to help. It says in the hint to make sure you pay attention to the solute, right? Water follows solutes. So if we click the items in the membrane, some of them aren't going to do anything. And it'll tell you that. If you click on this, this is not going to help you, okay? What's going to help are these things. More specifically, this guy, because this guy is going to help bring sugar in, okay? But we have to also put the channel proteins in to help move the solute across. We need to get the sugar across. See how the sugar is coming through? Once the sugar comes through, hopefully the water will come through. So if we put more channel proteins through, sugar comes through. We want to keep as much water inside the cell. So we're pulling sugar into the cell, which is going to pull the water into the cell. And we're going to keep doing this until it tells us we've done enough. Come on. It's not letting me move the protein. Once the sugar comes in this red guy, you got to click on it. It won't go through if you don't click on it. There we go. Okay, so good job. And then that's it. We answer all the questions, go through and answer all the questions, highlight your correct answers, and then you're done.